Alright, so I was already planning on making a video, an in-depth video for absolute beginners, but for today I'll just do like a quick and dirty one, and I'll make the more in-depth video another time for other people. The actor I'm gonna do the init function for the flying floor tiles that are in Fire Temple. I'm choosing this one because it shows a bunch of the tools that I want to show how to use. So I'm assuming that at this point you've set up the repo and you get the good old okay, everything's good to go. If you have any questions about setting it up, feel free to ask. So before we even start working on the file, first things first is the diff script. There's an option -O that lets you view symbols in the diff, and it's very, very good. But you need to give it a reference for those symbols. What the heck? Okay. You need to give it a reference for those symbol names. So after you've built and you got okay, then you want to go into your repo and create a folder called expected. You want to name it exactly that. And the idea is to copy the build folder, which gets generated when you build, into expected. So you literally just copy and then paste. I'm on WSL2, so my files are in Linux right now. So pasting from Windows is hella slow. So I'm gonna do it from Linux. I'm just gonna copy recursively build into expected. And now inside expected you have build. A common mistake is people take the contents and put it in expected. You want it to be like this. Okay, so I'm doing the flying floor tiles. That is Yuka Bune. Yeah. So I'm gonna open that. And I want the header too. I'll keep the C file on the left. Split left. I keep z64actor.h and z64.h pinned. You'll be using these a lot. And this is the actor instance. So, before you even get to doing functions, the first thing I recommend that you do is you take the data from the assembly file and move it into C. This approach is probably not great for really big files like those in code, but for actors this is more than fine, and it makes things a lot easier. So, the easiest way to find the data file is to just search for the initvar name, because this is in that file. So I'm just gonna do a Control-Shift-F, and here's the data file. Now, initVars is already generated in every actor, so you don't need these. But I'm gonna take everything else and move it in, and the order matters, so it has to go below the initVars. Gonna uncomment them, and this is good. Now, it doesn't matter what type these are at the moment, so I'm gonna make it simply an array of words, an array of S32. So I'll do that real quick. You can skip the video or whatever. Cool. So I have a plugin that lets me run our format script very quickly, so I'm just gonna do that to make it look a little less long. So, like I said, it doesn't matter what type these are. Right now these are just going to be raw bytes, and I have them formatted as an array of words, and that's more than fine. So after it's been moved, all of the data from this file is now in C, so we don't need this file anymore because it's all in here already. So I'm going to open up a file called the spec and search for Yuka Bune. There it is. So this file basically includes different object files in the right order of the ROM, and since I've moved data to C now, I don't need this at all. So I'm going to comment it out for now, but eventually you'll erase it completely. So if I save everything and head over to my terminal and do make, I should get okay. Cool, that means I moved everything correctly. Now, I have messed this up plenty of times, so I want to show what you should do if you don't get okay. Say for somehow, some way, I managed to copy this twice and name it something else. So now I have too much data, and when I run make, I'll get an error because it doesn't match anymore. Failed. So we have a script called firstdiff.py. You don't need to give it any arguments. It says that the first difference is in the DMA data table. That's just because everything's shifted. But the first real difference is here in the actor I'm working on. So it gives you the ROM address, which allows you to diff. The diff script isn't great for this because this isn't a problem with code. So I personally use vbin diff in Linux. You can use hxd, but I don't really like its diff. I find this much better. So I'm going to do vbin diff on the base ROM and the Zelda whatever ROM that gets generated with your code. And you see the checksum is already bad. So I'm going to grab the address of the problem and then do G paste to go to that address. And then you can see already that FCFF is fine up to the collider there. It's good until 10. And then you can see that in the original it goes straight to the segment address, but in mine it's duplicated. So that's how you can spot your issues, just with like a binary diff. And then you remove your problem. And then you're good to go. Cool. So now we can get started with functions. I'm gonna grab the file for init. I just search for the name and it comes up. And this is init here. I'm going to pull up MIPS to see. I use the online version. You can use the script, obviously. It's whatever you want to do. I've got some crap in here saved already. So I'm going to paste in here. And now, I've mentioned this before, there's the context that MIPS to see takes. So I'm going to show how to set that up. It's not the most useful when you're starting with a init, because obviously you don't really have too many fields, but it helps to have the prototype and stuff. And it becomes more useful as you fill out the actor struct. And it obviously has structs from everything else. So, clear this up. We have a script that generates the context. It's in the tools folder. And it's called m2ctx.py. And it takes the path to your C file as an argument. So I'm just going to do copy path in VS Code. And then it goes to the root. I usually just open it like this to bring up the folder. So it's right here, context.c. It's in the root of the OOT folder. And we're going to take the whole thing and paste it into this box here. And then init is of course always void, so you can check that to make sure. Cool. So, there's the whole this thing, which I'll explain real quick. So init, destroy, update, draw, and anything else that gets called by code pretty much, or like outside of the actor, is going to take a plain old actor. It's not going to be a Yuka-bune. So whenever a function is taking an actor, we call it this X. And whenever it's taking the actual actor, we call it this. So this is relevant because right now my prototype is taking actor this X, but in MIPS to C, it would be a lot easier if these all said this and used the actual fields from Yuka-bune. So what I'm going to do is I'm going to change the type for what init takes in the context to be wrong on purpose, so that it thinks that it's a this instead of a this X. It's just a little trick to make things easier. So I'll go ahead and copy paste. And again, I have the format script. This format thing that I'm running, format document, uses Clang format, and you can get that. You have to install a couple things. I can show you how to do that another time, but format.sh does the same thing if you wanted to run it, which you always need to run those before you submit stuff, but that's not relevant right now. Okay, so this is my MIPS to C output. Obviously this can be cleaned up a lot. I'm gonna go ahead and comment out the include. This just takes the assembly and puts it in the place of the function. So since we're gonna do it in C, you can take that out. So I'm just gonna move down the line. I tend to fill out actor fields first. You also have that script that you made, that program that will get your fields, but I tend to see what fields are being accessed and fill them out before I do anything. But for the sake of this demonstration, I'm just gonna go in order. So first is a init chain. A init chain takes a plain old actor, and MIPS to C is casting it to an actor, and this is not what we want to do. You want to instead, and since I have two of these, I'm just going to do a find and replace. Instead, you want address of this .actor, like that. So that's good, and then it's casting my S32 array here to an init chain entry. It's obviously not needed also. So this is where you will use the init chain script, because you know that this right here is an init chain. So I'm gonna go to the tools folder, and what is it called again? I think it's iChainDis. Yeah, iChainDis.py. So I'm gonna run iChainDis, and it takes the address, the ROM address. Oh, right. So I need a ROM address. We have VRAM. A nice tool that we have to get the ROM address is called siminfo. And I'm just going to give it the name of the symbol. Huh? Oh, I'm in the tools folder. Cool. This script for some reason is not. I'll just run it using Python, whatever. So give the name of the symbol, and it gives you this. So ROM address is what I want right there. So I'm gonna go to tools, and then do iChainDis.py. It takes a ROM address, and it takes a path to the ROM. It grabs the iChain straight from the ROM. So I'm gonna do ./base/rom.c64. Cool. Do I have the args flipped maybe? Yeah, cool. Base rom.z64 ROM address. There we go. Sorry about that. So it gives you the iChain. You don't have to worry about parsing the numbers to make sense of the iChain and all that. This will take care of it for you. So I'm gonna drop that here. Now it names it for you with our naming scheme and everything. S means static. It's like a local variable. And then it has the styling and everything. But because right now I don't have data fully migrated, I'm gonna instead just drop it in a comment just to be able to fix it later. I'm gonna remove static too, just so that I can, oh, I meant to, oh, never mind. So yeah, I'm gonna put the name in a comment, remove static, and use the symbol name just for now, just because it's easier. So that's good to go. iChain should be good. Actor shape init, address of this actor shape is good. Float, takes a float, right? Yep. And then the shadow draw function, do not need to cast it to void. And you do not need the address symbol for functions or arrays. So I don't have it here either. And then that takes a float, that's fine. Cool. So now here's some MIPS to C, just creating temps for no reason. It's very common. Over time, you'll be able to recognize when a temp is useful. And I'm sure you've seen it too, because you've worked with MIPS to C for your rewrite. So this is not needed, but it's showing us that the cylinder is going to be at actor plus 154. So I'm going to go ahead and add it to the struct. 154 is going to be, oh, I am dumb. I meant to do minus 8 bytes. Where's my calculator? Okay, so that's going to be our cylinder, and I know the type by heart. Oh, and MIPS to C. Oh no, that's the init. I know the type by heart, but if you need to get it, it gets passed in here. So it's a collider cylinder, and I actually don't remember the size, so I'm gonna look up the thing here. Size 4C. It's here in collisioncheck.h 4C. So collider cylinder. We always call these colliders by default, and then if there's multiple, then you can name them. It's just our naming scheme for the time being that we stick to. So it starts at 154 and is 4C bytes big. So that's it. There's no more after that. Cool. So instead of doing this temp nonsense that MIPS to C likes to do, I'm just going to pass in directly the rest of this collider. Same goes for that, and I don't need this anymore. Cool. So now is the collider init data. Ooh, I spelled it wrong. Collider. Collider init data. So we have a script for this as well. The cylinder init data is this guy here. Now, this tool is in tools/overlay helpers. And this script is set up a bit differently. It can take a VRAM address and doesn't need the base ROM. Eventually we'll make iChain do this too, but nobody's gotten around to it. But /collider init, I forget the args. It takes the address first. So I'm gonna grab the address from the symbol name here, making sure not to copy the D. And the type, MIPS to C, put it here for me with a cast. If it's not there, again, look at the prototype. It takes collider cylinder init. So I'll drop that there. And then it gives you everything that you need. Drop it right below here. And again, just to make things easier to build, I am going to keep the name because this is what you want to call it eventually. But for now, I'm just gonna have it called that. Cool. So this is not an array. What's the issue here to complain about? Oh, right. I'll get to that in a second. So this is not an array, so I do need the address symbol for that. And this is giving me trouble because these fields are not named. The script doesn't grab them from here. That's just because if we change it, we don't really want to hard code it in there. So 50 is the scale. This is going to apply to the whole vector. So you don't need to put any of the specific fields. and 4C is unnamed, so that's fine. Cool, these guys are good. Params, this I'm sure you know already, but this is what the hacking scene generally calls the actor variable. This gets incremented by 1. So I'm gonna just do ++ like that. Cool. 152 is a field, and MIPS2C very helpfully put a cast here because it thinks it's the wrong type. It's trying to assign a byte to a char array, but that's good for us because it's very easy to see that it's a byte. So at 152, MIPS2C likes to assume unsigned a lot, so I always do signed until proven otherwise, personally. I'm just going to copy the name because I don't know what this is, and our naming convention for unknowns is unknown, or unc underscore, and then all caps for the hex. So that's good, and then I'm small-brained, can't do easy math in my head, so I'm gonna just make sure. 6, right. And there is another byte after this, but there's this concept of struct padding, which you might be familiar with, I don't know. You don't need to specify that there's a variable here. If it's actually empty, it will automatically align this to the next word, because this type starts with a word, basically. I'm gonna assume that there's not gonna be another byte there at 53. That might be wrong later, but I'm just not gonna bother putting char filler there because I think that's just gonna be struct padding. So 152 equals 0, get rid of that done cast. Now 14C is an address, or a function, and it's a good old action function, which is a good time to show the type def. So every actor has their own type def for their action function. I never know the syntax for it, so I always just grab it from another actor. So I just search, oh god, I have caps lock on. Search for action func. I'll grab it from player, sure. And then I'm going to change this to en_ukabune action func, and en_ukabune as the first arg, like that. And then it said the action function is at 14C, so I will do this. This one, there might be a variable at 50. So I'll just put it just in case. I didn't really explain struct padding all that well. I can talk about it another time. But basically, it depends on what types are around it, on how it will align. What type the thing is, and the type of the things around it. But yeah, I'll go over that some other time if you aren't familiar. Anyway, we have the new type that we just created, and it is the action func. Cool. Back in the function. I'm going to change this to action func, and then take away the address symbol, because function pointers do not need the address symbol. And it's giving an error because it can't find it. It's defined below, so we're gonna need to do a forward declaration. Of course, I'm sure you know, it is very, very common for action functions to have a prototype of actor and then global context. So I'll make the first arg a ukabune, and then global context, and they're very commonly void. I'm just assuming that because that's the case like 99% of the time. But yeah, why is it giving me a problem? Init is wrong because remember we changed the actor thing. Oh, that was just VS Code being dumb. But we changed this in MIPS to C for that little trick from before. So we're just gonna change it back to what it should be. Cool. And last but not least, it does 150. Cool, so there is a variable here. It's gonna be a short. Is equal to 1D times 10 plus 14. I actually have no idea what the hell is at 1D. Oh, it's params. That's really strange, I've never seen that. It accesses the first byte of params directly. What the heck? That's really weird. I hope I don't need to do like some weird cast or something. I've never actually seen that before. I guess we'll see. Cool. So this looks mostly good. We got rid of these temps, remember? From the collider. It's giving me errors because I went over the thisx thing. Every file has a macro defined. Holy shit, my cat's going crazy. Every actor has a macro that will do the cast of changing thisx into the actor. And to use that, you simply do... I grab the type from here. You do enucabune this equals this in all caps, which is the macro. So now the thisx is being casted to a this, and now you can treat it as this actor. So that all looks pretty good. That I need the underscore, and this I need actor.params for that to be all good to go. So this should be good. I'm still confused about this 1D thing, but we'll see what happens. So to do the diff, we're gonna do diff.py. The options are MWO. This will use -O is the thing I was talking about with symbols, so that it will show symbols on the diff, and MW will let the diff automatically update whenever you save the file. So my files are saved, good to go. I'll paste the function name. So diff.py-mwo function name, go. Oh, I'm not in the root. Cool. Looks mostly good, except, yeah, that's so weird. Okay, so I have regallic issues and load byte unsigned 1D. Do I need to cast params to a byte? I guess. That's so strange. I've never seen that before. Okay, cool. So that worked. I still have register issues. I'm gonna go ahead and bet on ordering. So the order of your statements, even though the order of my statements is correct in the assembly, it can still be wrong and affect just registers. So I'm going to use prior knowledge that action func is very commonly set last. Oh god, I didn't press the right thing. So I'm going to do Alt and then down to move the line down. And might be okay. Nice. And the whole function is done. So you'll pick up on patterns like that, like the action func being last, for example. Over time, you just learn all those different patterns to what the devs did. And yeah, so that's that. And I highly recommend moving in order through these functions. So if I was to continue this file, I would do this function next, and then whatever action function those call. It really helps you to make sense of, you know, what the actor is doing, and helps you name things and whatever. And you've got update and draw, obviously. But yeah, this actor's really small, but I'll probably do the whole actor when I do that video I was talking about for everybody. This will do for now though. Of course, if you have any questions, just hit me up. It should be good to get you started though. It's a bit longer than I wanted it to be, but it should be all the info that you need.